Hey folks, so we are in section 3.4, the application section, and I'd like to work two examples for you. The first example is this area of a picture. The mat around the picture shown measures X inches across. You can see that there in the example. Which equation says that the area of the picture itself is 600 square inches? Now we know the area is going to be length times width. And so let's talk through this a little bit. We only want the area of the picture. I don't want the area of the frame. And I know that the frame itself is going to be 34 inches tall and the frame itself is 21 inches wide. But I only want the area of the picture, not the frame. So if you think about this, that 34 inches, I'm going to take away an X down at the bottom, but I'm also going to take away an X at the top because the frame is X units wide or X inches wide. So if I take away an X and another X from that 34, it's going to be 34 minus 2X. Same thing with the 21 inches wide. If I take away an X inches on the two sides, that's going to end up being 21 minus 2X. So then let's talk about the area. We know area is length times width. So my length is going to be 34 minus 2x. I'm sorry, that's my height. My length, my width, is going to be 21 minus 2x. And our directions told us that this was supposed to equal 600 units. So when I look at it like this, I can easily tell that this is going to be part B. And then I'd like for you to jump down to the farm question. The area of the fenced-in region. So we have a farmer. She wishes to enclose a rectangular region bordering a barn with fencing as shown in the diagram. Suppose that X represents the length of each of the three parallel pieces. You can see here that I've marked in my picture which ones are X. This one here, and this one here. And I actually just erased those, so these three are my values of X. She has a total of 600 feet of fencing available. Well, if she had a total of 600 and she's already used up a single X here, a single X here, and a single X here, then how could I find this last remaining piece of fence down here? This piece of fence is going to be, and if you take a look at how I've set this up, all four pieces added together will be an X plus an X plus an X plus something to equal up to 600. So I have made that a little bit simpler to say it's 600 minus 3X. So that missing piece then, part A, what is the length of the remaining piece of fencing? That piece of fencing, this piece right here, is going to be 600 minus 3X. Part B says to determine the area that represents the total enclosed region. Okay, so we know once again that area is going to be length times width. And the length of this is going to be 600 minus 3X. The width of it is just X. So then if I go ahead and distribute to clean this up, I'll have 600X minus 3X squared. Clean that up a little bit more just by trading them around to put it in our normal quadratic form, and that's negative 3x squared plus 600x. That's part B. Part C, what dimensions for the total enclosed region would give an area of 22,500 square feet? All right, so let's take our area formula and let's set it equal to, I erased a little bit too much there. Try that again. 22,500 is equal to my area of negative 3x squared plus 600x. Now, what I chose to do, and you already saw this, is to divide all of my terms by a negative 3 so that we can clean this up. So take all three terms, divide by negative 3, and you'll get this equation, which is very close to our quadratics. So let's get that negative 7,500, and let's move it to the other side. Remember, you have four methods of solving quadratics. You've got the zero product property, you have the square root method, you have completing the square, and you also have the quadratic formula. On this one, I personally chose to use factoring. Set each piece equal to 0 and solve so that you'll get either x is equal to 50 or x is equal to 150. All right, so now let's take a look at how this would play out. And I've drawn my barnyard again. If all three of my parallel pieces are 50 feet, then that would mean the remaining piece is 450 feet. So the dimensions of my fenced-in area would be 50 by 450. If my fenced-in region were 150 feet, then those three parallel pieces would be 150 feet, and the length of the barn would be 50 feet. So this would be a 150 by 50. Honestly, either answer is good, but I think that the 150 by 50 probably is the more realistic answer, simply because I'm not sure that a barn is going to be 450 feet wide. But I could be wrong on that. I haven't measured too many barns.